continuing search for life, 2 Viking spacecraft were launched by the Lewis Titan Centaur rockets to land on Mars in 1976. I'm Larry Ross, Director of Space Programs at NASA's Lewis Research Center in Cleveland, Ohio. This is the 8th program in our 13-program series called Journey Through the Solar System. During this program, we will see 2 NASA films made about the unmanned Viking missions. The first film is called Mars, Is There Life? And was made before the landings. The second film was made after the landings. Please watch carefully to see how our knowledge expands. The second film actually corrects some of the first film's predictions.
In the distant past, it may have begun like this for a very young planet called Mars. It was an age of volcanic activity. With volcanoes came their gases, including water vapor. These gases condensed and formed rain. In its beginning, it rained for countless years. The rain cooled the planet's surface. The rain eventually formed streams. These cut channels in the planet as the waters flowed over the terrain. Waters continued to grow larger in size. Streams widened. Small streams emptied into larger ones, creating rivers or oceans. This is the past history of Mars as some see it. This is Mars today. The once powerful volcanoes of Mars appear to be extinct or dormant today. Time and erosion have covered their once molten lava with a mantle of dust. Yet volcanoes are still present, and larger than any on Earth. Olympus Mons is the largest known volcano in the solar system. It is 3 times higher than Mount Everest. Mars also has a system of canyons. The U-shaped walls indicate that rock slides and avalanches have helped shape them. 4 times deeper than the Grand Canyon, these canyons might be 150 miles wide. They may extend over a distance of 2,000 miles. What forces could have formed these canyons, and when? And what about the water that once apparently filled these eroded channels? Once these may have been rivers or tributaries. Today the water is gone, leaving behind dried-up riverbeds. What happened to the water? When did it disappear? and what removed it. The water that may still exist on Mars is probably located in part at the poles, existing as polar ice or frost. It is joined there by frozen carbon dioxide in temperatures of minus 190 degrees Fahrenheit. This is the coldest place on the surface of Mars. Although water appears to be frozen in the ice caps, and although it may exist in the crust as permafrost, there is relatively little water on Mars. Mostly, this is a planet covered with dust, and the dust is moved by winds. Usually, the Martian dust storms last only a few days, but they carry dust up to speeds of 250 to 300 miles per hour. The dust storms have apparently contributed to much of the erosion that has taken place on Mars. The dust storms have helped shape mountains, volcanoes, and other surface features. At times, the dust has even appeared to have formed dunes. So Mars is not without Earth-like features, although portions of its surface are pitted with impact craters. If Mars is so seemingly desolate, apparently covered with little water or oxygen, what could live here today? And further, how can we determine if life presently exists on Mars? The answers on how to detect Martian life are found aboard the Viking lander that rests on the planet's surface. Its cameras, with their mirrors, show us what is on the planet. Yet they are controlled from the Earth. Certain instruments measure the velocity of the winds and provide information on a variety of surface and subsurface conditions. After traveling 440 million miles for nearly 1 year, one of the most important things this craft must do is to reach into the Martian soil and return a sample to the lander. This would be an easy task on Earth, but on Mars, machines must act as our hands. Returning the soil to the Viking lander is the first step in searching for the answer to a question that can change man's way of thinking. This desolate planet, if it has life, could alter the thought that Earth alone has living creatures upon it. So the journey of the soil back to the lander is one of great importance. Once the material reaches the spacecraft, it is sifted as it falls through an opening into the interior of the lander. Some of the material falls into a chamber where it can be tested for the presence of life in a biology experiment. In this chamber, the soil is moistened with a liquid that includes food that Earth microorganisms thrive on. A sample of the Martian atmosphere is pumped into the chamber, and then the weight. If there are microorganisms acting upon the food in the soil, they will give off a gas. The gas will mix with the Martian atmosphere, and when it is analyzed by chemical detectors, it may reveal that life is present. While the first experiment is taking place, some of the soil is also falling into another chamber for a second biology experiment. This time, the soil is also moistened with nutrients, but the nutrients are tagged with radioactive carbon-14. If the organisms are in the soil sample, they will feed on the nutrients and pass the radioactive carbon off with their gases. The gases can later be analyzed by other equipment aboard the lander, and the presence of radioactive carbon will indicate the presence of life. In the third and final biology experiment, a sample of the soil has fallen into a third chamber where it receives a small amount of moisture and an atmosphere of carbon dioxide gas tagged with radioactive carbon-14. Simulated Martian sunlight is introduced, and if plant-like organisms are present in the soil, they will capture the carbon-14. Later, the original carbon-14 gas will be flushed out of the container, and the chamber will be heated to over 1,000 degrees Fahrenheit. If there is carbon-14 in the soil sample, it will be detected when released in the heating process. This would indicate plant-like organisms existing on Mars. But what life exists on Mars today? Could there be creatures like those that abound on Earth? Exactly what forms of life could exist on Mars? The biology experiments are designed for the very small organisms, partially because of their abundance and their ability to survive environmental extremes. The Martian planet abounds with mysteries, from its volcanoes to its bleak landscape. We know this place only from a great distance. Its secrets are there for us to discover. But if we do not find life on Mars today, it may mean we just looked in the wrong places, or searched with the wrong instruments, or came at the wrong time. But if we do find life on Mars today, it will mean that life on Earth is not an isolated instance, and it will offer further evidence that we are not alone in the universe.
There were high hopes that the Viking missions might find clear evidence of life, but the findings were not clear, as we will see in a NASA film called 19 Minutes to Earth.
It was not just another day on the planet Mars. A spacecraft had successfully landed and was monitoring this unique planet. The information was transmitted, and it took 19 minutes to reach Earth. Even from the beginning of the Viking mission to Mars, we began to assemble more than just pictures of the Martian surface. As information was received, we began to piece things together and to understand a place, a planet other than our own. As the planet was orbited, we began to understand Mars through a series of incredible photographs. Photographs that, when assembled, told of the planet's history. We found remarkable evidences of running water. Here are just a few of what appear to be dried-out riverbeds. Although other evidence states that liquid water could not flow on Mars today, we can see that at one time in the past, liquid water must have flowed on the Martian surface. When did this take place? And was there life on Mars when these channels were filled with water? We now know where part of the Martian water is today, and that is in the permanent polar cap. Previously thought to be frozen carbon dioxide, we now have evidence that the permanent polar cap is largely composed of water ice. Here you can see channels formed through melting of this ice. Other photographic evidence reveals a closer look at the Martian Grand Canyon, a system of huge canyons extending for 2,000 miles across the planet. What forces caused the surface to split apart in so many places? This raises the question as whether Mars is dynamic and active. Is it similar to Earth in that its volcanoes erupt lava on the surface? The evidence is clearly seen that Martian volcanoes have erupted in the past, and from this mission, we know that at least one quake has taken place recently on Mars. So Mars is alive, and we now have a general idea of the thickness of its crust. Day-to-day environment of Mars, and obviously many have been reduced in part to the Martian dust. Let's examine the Martian environment as told to us through the Viking mission. To begin, the temperature. The temperatures appear to vary the same day to day, starting as an approximate low average temperature of 190 degrees Kelvin just before the Martian dawn. The temperatures rose to an average upper temperature of 240 degrees Kelvin. This temperature range appeared day in and day out relatively the same, almost to the point of monotony. Next, the atmosphere. The extremely thin upper Martian atmosphere consists of some familiar gases. The most abundant is carbon dioxide, a gas that we breathe out. There is carbon monoxide, dangerous to life as we know it. Argon, oxygen in small amounts, atomic oxygen, nitric oxide, and a small but significant amount of nitrogen. Additional argon and nitrogen data reveals that Mars once had a much denser atmosphere, which could have supported running water. An analysis of the Martian soil shows an iron-rich clay with an unusually high amount of sulfur. The elements that make up this clay are familiar. Iron, silicon, magnesium, aluminum, calcium, and sulfur. In terms of abundance, silicon and iron are in the largest amounts. Silicon is also one of the most abundant elements in the Earth's crust. Magnesium, aluminum, calcium, and sulfur exist in significant amounts. The soil samples appear to be very similar in composition at the two different sites on Mars, but nowhere were organic carbon compounds found in the soil. The absence of organic carbon compounds affects the interpretation of the 3 biology experiments conducted on the surface of Mars. One experiment used a sample of Martian soil moistened with a liquid that included foods that Earth microorganisms thrive on. A sample of the Martian atmosphere was pumped into the chamber, and if there were microorganisms in the soil, the gases given off would later be detected, possibly indicating the presence of life. Let's take a look at the results of this experiment. If there is life, the gases should vary over the days shown. This data does not exclude the possibility of life, but neither does it strongly support it. The second biology experiment involved another sample of Martian soil, also moistened with a liquid containing nutrients. But this time the nutrients were tagged with radioactive carbon-14. If the organisms were in the soil sample, they would have taken in the nutrients and passed off radioactive carbon with their gases. The gases, when analyzed, would have indicated the presence of life. Let's take a look at the results of this experiment. The soil samples behaved remarkably similar at both landing sites on Mars. Here is a graph of the results at one landing site, and here is the graph of the same experiment at the other landing site. The similarity is remarkable, showing a reliable experiment, and the immediate change from radioactive carbon dioxide to carbon monoxide strongly suggests the presence of life, although there are non-biologic explanations. Still, let's compare this experiment conducted on Antarctic soil to that on Martian soil. By itself, you can see this experiment could favor the presence of life. But remember the first experiment, no organic carbon compounds, and finally, our third experiment. In the third and final biology experiment, a sample of the soil was placed in a chamber where it received a small amount of moisture and an atmosphere of carbon dioxide gas tagged with radioactive carbon-14. Simulated Martian sunlight was introduced, and if plant-like organisms were present in the soil, they would capture the carbon-14. Later, the original carbon-14 gas was flushed out of the container, and the chamber was heated to over 1,000 degrees Fahrenheit. If there was carbon-14 in the soil sample, it would have been detected when released in the heating process. This would indicate plant-like organisms existing on Mars. Let's examine the results and see if life was indicated by this experiment. First, the data itself. Let's take a look at this information as shown on a graph. From this information and supporting evidences, we cannot conclusively say that life is or is not present in the Martian soil. With certainty, if life does exist on Mars, it most likely is in relatively few numbers. One final discovery in the Martian mission dealt with its moons. An extremely close flyby of Phobos has given us information that could lead to invaluable data concerning the origin and evolution of the entire solar system. Are the Martian moons captured asteroids? And are they slowly being pulled apart by the Martian gravity? While this mission has answered many questions, it has raised still others.
We do not yet have conclusive evidence on whether or not some form of life exists on Mars. Some data support the possibility that Martian life could conceivably exist. The Mars atmosphere includes all the basic materials needed for life: nitrogen, carbon, oxygen, and water vapor. Mars ice caps contain much water. Summertime daylight temperatures at the equator are about 80 degrees Fahrenheit. But there are also data that are contrary to the notion that Martian life could exist. The atmospheric pressure is only about 1% that of Earth, a pressure that would cause animal blood to boil. Water would vaporize instantly in the thin atmosphere. There is not enough ozone in the Martian atmosphere to block life-damaging radiation. Temperatures at the Mars equator fall to as low as 150 degrees below zero at night. Clearly, more study is needed to see if life exists on Mars, or if it once existed and perished there. Scientists envision an unmanned robot, a surface rover, to be sent to Mars to drive to secluded valleys to search and probe for life. This Mars rover would weigh about 220 pounds. Other proposals are to collect and return samples of Mars soil to orbiting Earth laboratories for analysis. Next time, we will take a look at Jupiter, the next planet beyond Mars in our solar system. Until then, this is Larry Ross saying goodbye from NASA's Lewis Research Center in Cleveland, Ohio.